everybody, this is part 2 of sum of the first n terms of an arithmetic sequence. And in these ones, these look a little bit different because we have a summation notation. This little e sign is a sigma or a summation notation. All this means, okay, is we're going to take n and we're going to plug it in for this right here into this equation, but we're going to do it many times. We're going to take 4 times 1 minus 1, and then we're going to take 4 times 2 minus 1, and then we're going to take 4 times 3 minus 1, and then we're going to keep doing that until our final n value, which is 4 times 29 minus 1. And then what are we going to do with all those? We're going to add them up. We're summing them. And we're wondering what this is equal to. So what we have is a sequence that is 3, and then 7. Let's do it vertically still. And then 11. And then 115. And what are we doing with these? We are adding them up. We can also write this horizontally as this equals 3 plus 7 plus 11 plus we're going to keep going until we get to 115, and then we're going to stop. And that's the sum that we're trying to find. Now, our n value starts at 1, but our final n value is 29. So we're trying to find the sum. That looks like a 5. I meant to write an S. The sum of the first 29 terms. Now, what's the equation for the S of n? That is n times a sub 1 plus a sub n over 2. So for this one, we're actually already given n. N is this final piece right here, which is 29. A sub 1 is our first term, which we found is 3. And a sub n is our last term, which we found as 115. So the sum is going to be n, or 29, times our first term plus our last term divided by 2. So the sum, the first 29 terms, after some simplifying, is 1,711. Okay? So as long as you understand that summation notation, it works out okay. Let's go through one more example to hopefully ingrain the summation notation in your mind. So here we're told to compute the sum from k equals 1 all the way to k equals 312. So again, what does this mean? Well, we take 3k minus 4 and we plug in 1 for k, and then we plug in 2 for k, and then we plug in 3 for k, and then we keep going until we finally plug in 312 for k. And then what do? We sum them or add these all together. And what do we get? That is the question. So we use the equation, the sum of the first n terms is equal to n times a sub 1 minus a sub n, or sorry, plus a sub n, all over 2. Our first term is equal to -1. Our second term is equal to 2. Our third term is equal to 5. And our last term is equal to 932. So I'm adding all these terms up, right? But I need to know n. N is this 312. Even though it doesn't, like on the last one, this said n right here, right? But it doesn't matter because the first n terms still go from 1 to 312. And then we need our first term, which is -1, and then we need our 312th term, or our a sub n, which is 932. So this sum of 312 terms is equal to 312, or n, times -1 plus 932, and then we go ahead and divide that by 2. So this sum is 156 times 931. Where did that 156 come from? 312 divided by 2 is 156. And then I say this as the sum of the first 312 terms is 145,236. So we can see why adding 312 terms would be awfully difficult, but with our equation it makes it quite nice. That is part 2 of sum of the first n terms of an arithmetic sequence.